Hi students, today we are going to learn about speed control of DC motors. Okay, so speed control of DC motors, we are having different methods. For DC shunt motor, we have different speed control method, and for DC series motor, we have different speed control methods. Okay, so normally in industries, there is a need of increasing or decreasing the speed of DC motors. To regulate that speed of DC motors, we use different methods to control the speed of the DC motor. For example, in our home we all are using fan, right? So we use regulator to control the speed of the fan of our purpose, right? Same like in industries also we use speed control methods to regulate the speed of the DC motors. Okay, now we will go the speed control methods of DC motors. First we are going to see the speed control method of DC shunt motor. Okay, in DC shunt motor we are having two different types of speed control. One is armature control method and the second one is field control method. Okay, first we are going to see about armature control method. So here in armature control method, the armature of the DC motor is connected series with the variable rheostat. Okay, this is the variable rheostat and this is armature of the DC motor. So these two are connected in series so that we can reduce or increase the speed of the DC motor by varying this rheostat. Okay. So DC shunt motor is connected with DC supply. This DC shunt motor is connected with DC supply. So here from when we are giving DC supply, the current IL passes through the variable rheostat. When it comes here, this current IL is splitted into two, that is half of the current will go to the armature and the remaining current will go to the field winding. Okay, so here by adjusting the rheostat we can get various speeds. Okay, when this resistance, when we are varying the rheostat, when we are increasing this value, armature current gets decreased. Okay, so when the armature current is decreased, the back EMF produced in the armature current, back EMF produced in the armature current get decreased, so that the speed is also reduced. Okay, so when we are varying the variable rheostat, when we are increasing that, armature current get decreased, and when the armature current is decreased, the back EMF is reduced. When the back EMF is reduced in the armature, the speed is also reduced, because speed is directly proportional to the back EMF. If the back EMF is reduced, speed is also reduced. If the back EMF is increased, speed is also increased. Okay, so here in this armature control method, it gives the speed below the rated speed. So this method is not widely used, and in armature control method the power loss is high and also it is very expensive. So this method is not widely used. Okay, and the second method is field control method. Okay, in field control method, this is the field winding, right? So variable rheostat is connected in series with the field winding. Okay, this is field winding and this is variable rheostat. These two are connected in series. Okay, as usual DC supply is given to the DC motors. So the current IL passes through. When it comes to this point, the current is divided into two. Half of the current goes to the field winding and the half of the current goes to the armature of the DC motor. Okay, so here when the field current, when the current flows to the field, so when the field current is reduced, the flux gets reduced. When the flux gets reduced, the speed is increased. Okay, since speed is inversely proportional to the flux, so when the flux is reduced, speed is increased. Okay, and in field control method it gives the speed above the rated speed, so the losses are small, and this method is highly efficient than the armature control method. And the this type of speed control method is very easy to control the speed. And the only drawback of this method is when the flux reduced, the torque of the DC motor is also reduced. This is one of the drawback of the field control method. Okay, so these are the two types of DC speed control method, DC shunt motor. One is armature control method and the other one is field control method. In armature control method, how the motor is connected, the armature is connected in series with variable rheostat, right? In field control method, from the name itself we can know variable rheostat is connected series with the field winding. Okay, there is a difference between armature control method and the field control method. Okay, next one is speed control of DC series motor. So we are having 4 different types of for DC series motor. First speed control method is field diverter method. Okay, so here in field diverter method, here we are connecting variable rheostat, that is called a diverter. Okay, so field diverter method means the variable rheostat is connected parallel with the field winding. This is field winding, so this is variable rheostat, this is connected parallel with the field winding. As usual, we are giving DC supply to the motor, and this is armature. From here the current IL is passes through. So when the current IL is passes through, the same current flows here through field winding, and when it comes to armature we will get the armature current. Okay, so here when the field current decreases, the flux also decreases. When the flux decreases, the speed gets increased. Okay, so here in this method the speed is greater than the rated speed. These type of methods are used in electric trains. This is field diverter method. Okay, so next second method is armature diverter method. So armature diverter method, from the name itself we can know field diverter means the variable resistor is connected parallel with the field winding. So armature diverter method means this variable rheostat is connected parallel with the armature. Okay, and the other thing is same, DC supply is given, the current passes through the field winding, and the armature current IA passes through the armature. When the IL increases, this field winding current also get increased, and the flux get increased. When flux increased, what will be the speed? The speed gets decreases. Okay, the current from the DC supply increases, series winding, field winding current also increases, and the flux increases. When the flux increases, what happens? The speed gets decreased. Okay, so here the speed is less than the rated speed, and this method is costly. Okay, and also this is unsuitable for hanging loads. For these applications, this method is unsuitable. Okay, and the third method is field tappings method. So field tappings method means field tapping method, that is field winding. We are having number of turns. The tapping will be increased or decreased depending upon that increasing or decreasing the number of turns of this field winding. The flux also get varies. Okay, when we choose different turns of this field winding, we get different flux. Okay, when we are using high number of field winding turns, it produces high flux. Okay, depending upon the number of turns, the flux is produced. So when the flux increases, what happens? The speed gets decreased. Okay, this is applicable for only small motors. Then the fourth type is armature resistance control method. So in armature resistance control method, these are connected in series, that is variable rheostat is connected series with this field winding. Okay, so this is, here we are giving DC supply, the current flows here. When this current decreases, this variable voltage gets decreased, and when current and this voltage get decreased, the speed also get reduced. Here the speed is very less than the rated speed. This is one of the mostly used method among speed control method of DC series motor. These are the 4 methods of speed control method of DC series motor. What are the 4 methods for series motor? First one is field diverter method, then second one is armature diverter method, third one is field tappings method, and the fourth one is armature resistance control method. Hope you all understand this video. Thank you.